Hi everyone, I thought I'd update you with this brightness project. So I've got the two monitors. When it's dark outside, I need the monitors to auto adjust and get darker. And when it's bright outside, I need the monitors to auto adjust and get brighter. And it's proportional as well. So if it's very bright, I need the monitors to be very bright. If it's very dark, I need the monitors to be very dark. So I wired something up. I wrote a sketch, as it's called, in C++ that got flashed onto the Arduino, and I wrote a C# application in Visual Studio. So I'm just going to show you this thing working. Now you can't really see it because the camera makes up for the lack of light, but I'll just do it anyway just to show you. So actually I could probably show you here somewhere. So here's the wall. It's currently dark. Now I'll turn the light up. You can see it's brighter. Now what's actually happening is the monitors are getting brighter as well. And I'll turn it down and the monitors are actually getting very dark. Now my camera's making up for it, so you can't really see it. But what's happening is it's working basically. Monitors get brighter when the room gets brighter and monitors get darker when the room gets darker. So this is the app now. So I kind of just threw it together. When I showed you last week, I threw it together. I just written it very quickly. And that's that. But now I've taken a bit more time, probably an hour or two, and I've made this a lot more efficient and I made it look a bit better. So I thought I would just show you that. Okay. Alright, so here's the app here. And if I turn the lights up, you can see that the brightness goes up. If I turn it down, it goes down, and probably about halfway, it goes halfway, and that's actually working. These adjustments here, I meant to tell you about these last time. So these are, okay, so if the lux is 100 lux, you might want the brightness to be 100% bright, in which case you'd have this set at 1%. Now if the lux is like 3, you might want the monitor brightness percentage to be 3. And basically this is all how it works. So the desired brightness is the lux multiplied by the adjustment, take away an offset. So that basically changes the low point. It's quite hard to explain, but basically you see here I've got lux 3. I could turn it off. Yeah, lux 2, and it's brightness, desired brightness -6. Now if I turn the thing right up, so maximum brightness with these lights is 27.5 lux, and I've used a formula that's here to basically say, okay, that amount of lux is 95% brightness. Now this is just for testing. In reality, the actual brightness should be like this. The actual settings should be like this. Now if I turn the lights right up, it shouldn't get as bright. You see there, it barely scratches the surface. It's 1% brightness, and that's actually correct. Now if I take that off the window and it's bright outside, it can get, from what I remember, well up to about 200 lux, in which case you would want them to be full brightness. Anyway, so I thought I would show you what I've done. So it looks better to start with. Now the actual app itself, I'll explain a few things. Now I don't think I explained this properly last time, so I'll explain it now. Let's zoom in a bit. I think you should be able to see that. So serial port, we're going to be using a serial port communication in the program, so I have to define that there. Double is last lux, so I always record the last lux value recorded from the sensor, and that's in case it gets stuck in a difficult situation and it needs to remember what the last value was. I won't explain too much of that. Environment get folder path, that's because later on you need to set the application path of Twinkle tray, otherwise it doesn't work. Data buffer. Now a data buffer is to store fragments of data that it's pulled from the Arduino Pro Mini. Now the first version that I created didn't have that, from what I remember, but now it does. So let's say it just happens to get a bit of data, but it isn't a complete line from the Arduino. Maybe it just happens to be half a transmission, which is unlikely, but it can happen. So half a transmission, or a better way of saying it is, if I was to look for data every, I don't know, every 1 millisecond, then depending on how long it takes to transmit some data from the Arduino, if it takes 2 seconds, you might end up with half of the data, which you couldn't do anything with. So if I got like, I don't know, what's the looks, 12 point, you can't do anything with that until you get the carriage return. So it's stored in a buffer. On form load, I set all of the port stuff, and I create an event, subscribe to an event, which basically means if the port has received data, then trigger this method to deal with whatever it is. I set this directory thing, otherwise the app doesn't work for some reason. Get ports, that's from this Win32pn entity thing, which I just googled to be able to get the port name. So that's like COM1, COM4, etc. Listen is fairly straightforward. If the port is not already open, then set the port to be whatever is selected, open it, and then invoke this. So invoke means if there's work to do on another thread, tell the other thread that it needs to do this work, you know. Update the labels, I won't tell you about that, it's nothing different there. So on data received, what's that one about now? Oh yeah, so on data received, which is the trigger thing, it's a little bit different. So a few more checks. So did I read line last time? Well, this time I'm saying read existing. That's so it doesn't block. So it just, okay, there's some data available. Read whatever's there, basically. Don't wait for a line. Just read whatever's there. If it's not nothing, which it shouldn't be if there's data existing, then add it to the buffer. So add whatever's there to the buffer. So now you've added it to the buffer. If it ends with RN, then we know that we've received the whole line. So show the indicator to true. Now the indicator is this little LED thing that I put on here. So it's grey, and then it flashes up with a green image if there's data there. Then we split it in case there are more RNs. So it could be that there's some sort of pause or delay, and therefore it receives 3 messages instead of 1. So if that's the case, it splits it and just takes the last one. So it's the length, take away 2, which means the last one. Pass that into the current looks. Now reset the data buffer because we've got a full line now, so we don't need to worry about that. If current looks is not last looks, in other words, if the value is changed, because remember that this is sending data every 100 milliseconds, and if the light hasn't changed, there's no point in doing anything with it. If it says here, like, I don't know what lux it is right now, but if it says it's 4 lux, and it's still 4 lux every 100 milliseconds, then there's no point in going further, because, you know, we've already changed the brightness. Then we invoke a method on the label on another thread, which we spoke about. Get the desired brightness. Now, the last desired brightness, that is a calculation that's done on the last lux that was received. Do a calculation, which is the calculation I've shown you before, which is this here, to determine what the brightness percentage should be. Okay. False, what's that? I can't remember what that is. Let's have a look. Make it safe. Okay, so we can calculate the brightness unsafe or safe. Now, if you calculate the brightness unsafe, it means give the raw result of the calculation, which could be -5 or something. I don't know. If you get the lux and you do the calculation that says, oh, we want brightness -5, that might be correct as far as the calculation is concerned. But you can't set the brightness to -5. So therefore we need an option to make it safe. So if auto is checked, in other words, if this is an automatic process, so they have this auto button ticked here instead of manual, because you can actually set it manually. Then set the brightness, make it safe, get the desired brightness and make it safe. True, what's true? Update the track, yeah. So if auto changes the brightness, it also needs to update this track here, so that it's kept nice, and then set the indicator to false. That's pretty much all of it. Show the indicator. So you have a label with an image list. Is it an image list? I think it's an image list. Yeah, image list. So you've got the grey image and the green image, and then you flip between the two. Get the last brightness. There's the calculation there. So that's how I go from lux, whatever lux might be. It could be 3, it could be 200, 300, That's how I go from that and convert it into a percentage, basically. And it's just something I made up. It's not been researched. It's not anything official. I just made it up and it works. Now, so we get the last desired brightness. If it needs to be safe, then we make it safe and then return it. Set the brightness. So to set the brightness, we create two tasks. One's for monitor 1 and one's for monitor 2. Now the two tasks, looks like we'll go back to that in a minute. Make brightness safe. I've already explained that. If it's less than 0, make it 0. If it's more than 100, make it 100. Right, so this is the task. Set display brightness. So we need the monitor number and the brightness level. Now, I thought at this point brightness should already be made safe. Let me just check this. Brightness. Yeah, I'd have to check that, but I think at this point it will already be made safe, so I'm not sure if that line shouldn't really be there. It should already be safe, but anyway, now this is the stuff that Twinkle tray needs. So it needs these arguments in this format here. Then I set up a new process using the process class, and then tell it to start. Now I believe this is something to do with command line. This process thing, it's something to do with the command line, and maybe this is why you have to set it these arguments in this manner. You know, command line arguments. I'm not exactly sure, but basically process class creates a new process. And then we look for the output. We want to wait for the word OK to come back. If it doesn't come back with OK, then the process has not started properly. And then we've got stop, which is quite common sense. The other things here I don't think I need to really talk about. Yeah, and that's it. So this is the second revision of the program. So if anyone wants to make a similar thing, I have actually looked on eBay and I couldn't find anything like what I've created. But I'm surprised actually, because it's really good and it works. Anyway, thanks for watching. Bye.